Hey everyone, how are you doing? I hope you have a great day. Today we're going to check out this Leetcode problem called find k-length string with no repeated characters. It is a mouthful, isn't it? So despite the name, it isn't really that scary. I've already made a video about a similar problem, but today this is one of the weekly preview problems on Leetcode, so I thought let's give it a go. In the previous video, I've already talked about the brute force approach for these kind of problems, so I won't go into that much detail about that, just mention a few things. You will find a link to that video in the description. Okay, so let's take a look at the problem. This one says, given a string s with an integer k, we have to return the number of substrings in s of length k with no repeated characters. What does this mean exactly? Essentially, we have to find substrings that are made out of k unique characters. Let's go through the first example. So the first input is have fun on Leetcode with k equals 5, which means that we have to find all of the 5 character long substrings with unique characters only, and it expects us to find 6 of these. These are the unique substrings that we have to find. How can we do that? But the most straightforward and brute force approach is to iterate through the string and take all of the possible substrings, which means we have to mark a start character, and starting from there, we have to increase the length of our substring. For example, if we take age as the first character, we can take age, HA, HV, up until this character. And after that, we can move the start to A. Starting from A, we take AV, AVE, up until this character. And after that, we have to take the next character and the next character until we hit the end of the string. We are basically moving 2 pointers at all times. What is the time complexity of such an algorithm? It will be big O of n squared, because we are going to have nested for loops in order to find all of the possible substrings. This seems kind of unnecessary because the requirement was that we have to find substrings with length of 5 in the first example. So do we really have to take all of the possible substrings? What if we only took the substrings length of 5? So if we start from the ith character, we are only going to check the substrings up until I plus k. In this case, if we take age as the start character, we are only going to check it up until f. And taking everything else after f is just unnecessary because those substrings will be invalid. So how can we apply this thought process for the other substrings? One possible solution was that we take h to f, another one is a to u, the next one is v to n, the next one is e to o, and the next one is f to n, but we have to notice that there is a duplication in this string. How do we want to resolve this? If we just go forward with the same logic, then the next substring we are going to take is u to l, which also includes this duplication. So we have to find a way to restart this process from after the duplication. Everything else we take after the duplication is probably going to yield a valid substring. In this case, it won't, because if we take the next substring from O to E, it is also going to include the duplication. We also have to resolve this while we restart from after the duplication. So the next substring we are going to take is from E to D. And the last substring we can check is T to E. Awesome, we cut a lot of corners, but we still have to take each and every character in this string and start iterating from there to find the substring's length of 5. So what is the time complexity exactly for this algorithm? It is going to be big O of n, because we have to iterate through the string, times the minimum of our ABC and K. And the reason for that is our ABC is 26 characters long, because we only care about lowercase English letters, and K in this case is going to be 5. So we have to iterate through the whole string character by character, taking a given number of characters forward. If k is bigger than the length of our alphabet, then there definitely will be duplications. Because if a substring is longer than 26, then it is guaranteed that there will be duplications from the alphabet. Of course, due to the nature of iterating through the string and checking all the k-length substrings, this is still going to include a bunch of unnecessary checks that we don't really have to make. But how can we make this better? So let's start by using the sliding window technique. In this case, we're going to use a window of 5 characters, and each time we move the window, a character will be added to this window and one character will be removed. We can store what characters are in the window at the moment in a set because we only need fast access, and the set can tell us in constant time if an element was already in the window or not. So first, let's initialize an empty set, and we can start constructing our moving window. The first 5 characters will be added into this set. There is no duplication, so we can do that up until F. And after that, we can move the window by 1 to the right while checking for duplications. So in this case, if we add U to the set, we also have to remove one element from the set, which is going to be age. This is our new substring. And of course, we have to add U to the set and remove age. So this is great because we don't have any duplications so far. So let's move to the next character. We're going to add N to the set and remove A. There are still no duplications. The next step is to add O and remove V. And after that, we can add N and remove E. So in this case, we are going to have a duplication because there is already one N in this set. What we can do is to start moving the beginning of this substring up until the first occurrence of the duplicated letter, which is N. And also we have to start removing everything from the set except O. So after that, we can add the new character into the set and start constructing this substring again up until 5 characters. So we can add the new character, add it to the set. This is still not 5 characters long, so we have to take more. We are going to add the first E to the set. And after that, we will arrive to the next E. And we notice that there is already an E in the set. So we have to resolve this duplication again. What we can do is to start moving the beginning of the substring up until the first occurrence of the duplication, remove everything from the set in this case, add E, and then we start the construction again. So we can add T, we can add C, O, D. There is no duplication. So the next time we are going to move the whole window by 1 to the right, which means we're going to add E and remove the first occurrence of E from the set and add the new E to the set. There is still no duplication and we just arrived to the end of the substring. There is no point in checking the remaining substrings after T because this was the last substring that could have been constructed with 5 characters. Okay, so the time complexity for this algorithm will be big O of n, and the reason why is we have 2 pointers that essentially go through this string, and each pointer will only touch each character once, even though it's a little bit confusing that we have a logic to move the start of the substring after the first occurrence of the duplication. It is not going to change the time complexity. In reality, the time complexity will be 2n, but since we don't care about the constant here, the time complexity can be reduced to big O of n. And our space complexity is basically big O of 1. And the reason for that is we already know that we only can work with lowercase English characters, and the content of the set can be these 26 lowercase English characters only. So we consider that as a constant. Alright, let's check out how it looks like in the code. First, we have to make sure that k will never be bigger than our input string's length, because in that case it would mean that we have to take a longer substring than the input string, which doesn't make sense, so let's try to avoid that. We can just return 0. And after that, we can initialize our result to 0 and create this new set. And the next step is that we have to initialize our sliding windows pointers, which means that we have to create a new left pointer, which we initialize to 0, and we will iterate through the string with the right pointer, what we also start from 0. So each time we step the right pointer, we can read that actual character. And after that, we have to check if there is a duplication. So this new character C resulted a duplication. If it did, then you remember we have to readjust the window after the first occurrence of the duplication. Or in this case, we also have to check if we created a longer substring than k. So while this new character is a duplication, or our new window is longer than k, we have to start removing the left character and also increase the pointer of the part of the substring. So with this, we can get rid of all of the unnecessary characters from the beginning. After that, we can add the new character to the set, and we also have to check whether this new substring is exactly k characters long, because if it is, then we can increase the result by 1 because we found an actual solution. And at the end, we can just return the result. If you found this video helpful, please like and subscribe, leave a comment or a suggestion. See you next time, have a good one, bye bye.